Hello friends, this is WA6YLR on the air today in FT8, but this should apply to any mode you're operating in. I have my favorite radio, which is the Icom IC-7300. I love this radio, and I know a lot of you out there do. But if you notice on the screen there in the upper center, there's an OVF, which is an overflow indication. I've seen this described on a couple of YouTube channels, but I really don't think they've pinned down exactly the correct answer for what's going on there. In order to understand what's happening there, let's take a look at a really simple Icom diagram of what a typical digital radio might look like. So you have the signal coming in on the antenna. It's going through some RF magic, which I didn't really show, filtering and attenuators and so forth. And then we'll give it some gain in order to preload the analog to digital converter. The analog to digital converter takes this wavy RF signal and it samples it into a digital format that the software-defined radio can do its DSP magic. Decode single sideband, convert to audio signals on AM or CW, and then it takes that and it'll convert that digital signal back to an analog through the digital to analog converter. And once we have that analog signal, then we want to give it an audio frequency gain so we can hear through speaker or for some headphones. What's going on here is really back here where the yellow box is, the analog to digital converter. We're trying to set the RF gain correctly to load that signal up so that it can be digitized correctly. If we have too strong a signal or too much gain in the system, then what happens is we end up mashing to the top and the bottom of these sample ranges, so we end up with an overflow. The radio can detect that we've got too strong a signal coming in, and it lets you know I'm not able to convert this properly to a digital signal, so you're going to get junk out the other end. So you can see from the block diagram, the really simple fix is simply adjusting the RF gain. Turn down the RF gain and you'll be able to preload the ADC and get rid of that overflow indicator. If you look on the radio itself, right near the mic connection, there's an AF and RF. The AF is the audio frequency gain, and that's this top ring here, top knob, and then the ring is actually the RF squelch. So I have the audio turned down so you don't get pestered in it on the radio. Let me turn the audio up a little bit here, and now we're not getting the overflow. There's the overflow. Now if I back off a little bit so you can see, I'm going to turn the RF amplification down until the overflow signal disappears. So you can turn it down. You can see the indicator here. Nominally on this radio they want the RF in the vertical to 11 o'clock position, and you can see the overflow indicator. Well, maybe not quite yet. Let me go down a little bit, and you can of course read it on the S meter in here too. What kind of noise is coming into the front end digital analog converter? Analog to digital converter. Got to get that the right direction. And that's the simple fix for it. Ideally, you would want to do that because you really get the best sensitivity out of the radio, prevent overloading that converter. And now on the flip side, you don't want that gain too low. If you go too far to the left, then you'll get an indication that your RF, there's a little signal there called RFG, which says your RF gain is too low. So that says you're not fully utilizing the complete range of the analog to digital converter. So you kind of want to find a sweet spot. I'm turning it back up. So I've got the RF gain down. Looks like I have to be a little bit below the 11 o'clock position in order to keep from overflowing that based on the signals I'm looking at tonight. So that's the simple explanation for what the overflow signal is. Happy times on the radio. Hope you're enjoying yourself. As ham radio operators, I sure do love this hobby too. And until next time, we'll see you later.